Okay, apparently here it's not the case. But if you look at the other one, okay, it's not the case either. Okay. So let's have a look at the kernel message logs I typically got. Yeah, I can try to. Okay, so if you look at the error message, I hope I'm not making too much information by French law and stuff like that, but still, so unable to handle kernel paging requests. You must have one before. No, we don't. Okay, so this is the first one. So it's all happening inside the VM1. Okay, you can see I'm controlling several registers, okay, by the value. So you have a typical call trace, and then after, you have a second bug, which is triggered while trying to handle this null pointer dereference bug. Okay, so this is the one due to the spin log. Here, it might be a write, an arbitrary kernel write, I don't know, but even if it's the case, okay, because here it's an invalid opcode, which is not supposed to happen, it's very likely that it's not controllable. Okay, it's a race condition. And at the end of it, we must have something like everything. Okay, scheduling while atomic. This is typically the case when you're trying to access a timer or something like that, and you have either interrupt disabled or you have a spin log left. So it's triggering a third kernel bug inside the memory. And here, most probably a fourth one. 3 bugs. Okay, 3 bugs. And here it died with the very same error message. And then we have one more. So actually, in this case, we managed to trigger a succession of kernel bugs by having this spin log problem, which is general to the kernel. So I don't know how long it is. One more kernel bug.
One question.
Okay, this is the final one. Just one sec. Okay, and this is the end of it. It's saying, okay, everything is fixed, but you need to reboot. Okay.
So right now you were able to crash the host from the guest.
Yeah, that's it.
Which product have you seen in the virtualization product which were subject to that kind of crash if you use your research?
This is only going to work with, this particular kind of bugs is only going to be useful if the kernel you are targeting is the same as the one of the host. So typically, it won't work with full virtualization systems. It's going to work with vServer. It's going to work with server zones. It's going to work with BSDJs. Okay. Sorry. Linux containers. But if you have a real type of virtualization where the hypervisor is running on a kernel which is different from the one you're targeting, most probably this won't work at all. But the good thing with the approach we've taken with the fuzzing is that since the virtualization is done in ring 0, and you actually do get access to the hardware, any bug you trigger, which for instance and disabled hardware or stuff like that is going to be for the whole machine, definitely. And another good point is that even if the hardware is emulated, it allows us to go very deep inside the hypervisor. So, for instance, if you're fuzzing interruption 13, which is writing to disk, okay, most probably you're going to harm the disk inside the virtual machine, but you don't really care. But you're going to, in the process, you're going to fuzz very deep inside the hypervisor, and this is what we want to trigger bugs and exotic code paths. Done? Like, thank you much for coming, and I have good years to everybody. Thank you.